Assalamu alaikum warahmatullahi wabarakatuh and a good afternoon to everyone. So today we'll be doing a tutorial on chapter 9, finding a centroid by integration. So I picked this problem from the textbook. Okay, so this problem we're asked to find the centroid x bar from the shaded area and the centroid y bar from the shaded area. So if you guys can recall, to find the centroid, usually for x bar, the formula is integral of x tilde dA over the integral of dA. Okay, and for y bar, okay, is just y tilde dA over the integral of dA. Okay, so this is the formula for the centroid, and now we can choose any element that we want. Remember that there's two elements. We have the vertical element, which is respect to dx, and we have the horizontal element, which is respect to dy. Okay, so which element are we going to choose? Because in this case they didn't really specify which element are you going to choose, but we have to choose either one of the elements and try to solve it in the easiest way possible. Okay, let me try to show you what it would be like if we were to solve using the vertical element. Okay, so if I were to do the vertical element like this, okay, the vertical element here, 1, 2, and 3, I think you guys will notice something, that it's a bit trickier, the vertical element, because we actually have two parts. This first rectangle, okay, you can see here, is being bound by this x-axis, okay, and by this graph right here. Okay, so that's where it's being held by, or bound by, in other words. Whereas if we look at the second example right here, I'm going to highlight in purple, yeah, just to make it look nicer. You can see that the second rectangle, which I've marked in red also, it's being bound by this graph right here and that graph right here. So it's technically two different sections. Okay, two different sections. So you have to analyze for section 1 and you have to analyze for section 2 and utilize the composite area formula, which I think, if you guys remember, it's something like this: x bar equals to x tilde a over summation of area A, and y bar is equivalent to this over this. Okay, and this adds an extra complexity to our problem, and of course will take you a longer time to solve the problem, because you have to find for section 1 and you also have to find for section 2 as well, which is very difficult. So therefore it's obviously not the right choice to use this element. We're gonna stick to dy. Okay, and I also show you why we stick to dy right here. Let me just erase this first. Okay, 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 cool. So if you stick to dy, actually what you can see is that your element is only being bound by two things. Okay, your element is only being bound by this particular function right here and that particular function right here, which I've highlighted in purple. So only two functions. So therefore you know the length is obviously going to be x2 minus x1. Sorry, x1, my whatever, not x2, x1, right? So x1 and this is x2. So obviously your element here would be x2 minus x1. Okay, then your differential area is just simply x2 minus x1 dy. Now how do I get x2 and how do I get x1? We have to rearrange the equation actually. Okay, so let's just try to rearrange the equation. Okay, let me rotate this page. Okay, all right. So this is for x2, right? So y equals to bracket h over a minus b, x minus x2 minus b, right? Okay, x2 minus b. So if I rearrange the equation, I get a minus b over h, y equals to x2 minus b. So x2 is equivalent to a minus b over h, y plus b. Okay, that's your equation for x2. How about x1? So we use this equation right here. So y equals to h over a x1. So x1 is equivalent to a over h y. Okay, so That made things a whole lot easier for us. So we can try to simplify our equation for dA. So our dA is x2, right? So a minus b over hy plus b minus x1, which is a over hy. And this whole thing obviously is with respect to dy, right? Okay. So let's just try to simplify stuff here. So we will therefore get a over hy minus a over hy. So you should only get b minus b over hy dy. So it becomes much simpler right now, right? The whole equation becomes much simpler. Okay, that's your differential element. Now how to find our x tilde and y tilde? Okay, so how do you find x tilde and how do you find y tilde in this case? Okay, so if we consider this our element, this is our x tilde, right? Our x tilde, and obviously our y tilde also we're gonna have to find, right? So we can see that x tilde actually depends on the x coordinate, because the x coordinate actually is the, sorry, my apologies, depends on the x and y coordinate, right? So you can see that our x tilde, okay, it's actually in the half of x2 and x1, okay? It's actually between x2 and x1. Whereas our y tilde, which is referring to the position in the y coordinate, is the same as y. It's the same as normal y. So y tilde is y because of the same position, whereas your x tilde is basically between x2 and x1. So it's just x2 plus x1 over 2. And let's just try to simplify this part a little bit so it become easier for us. So I'm going to simplify this a bit. So a minus b over hy plus b plus a over hy, and then we divide it by 2. Okay, what we get here? I get here 2a over hy minus b b over hy plus b over 2. Now 2, don't worry, it's just a constant. Don't worry about it too much. It's not a problem at all. Okay, and maybe you can simplify this further to a over hy minus b over 2hy plus b. Okay, much simpler. Okay, so let's go and find x bar first. Okay, let's rotate page 90. So x bar, as we know it, is the integral of x tilde with the respect to differential multiplied differential element over the integral of the differential element alone. So it is a over hy minus b over 2hy plus b. Okay, and you multiply this with your dA, which is what we've simplified earlier. All right, this one, yeah. So b times b minus hy. Okay, b times b minus hy with respect to dy, and then we have here b minus b over hy respect to dy. Okay, so the first thing we should do is try to simplify all these terms, right? We should try to simplify them as small as possible, so it'll be much easier for us to integrate later on, rather than, for example, integrating this whole chunk. And if you want to integrate this whole chunk, you can. You just have to use the product rule. I'm not sure if you guys are familiar with the product rule or not, but the product rule is something like this, which is just u dv plus v du, I think. Hopefully it's right. If it's wrong, please do correct me about it. I apologize. But we're just going to simplify this before we actually proceed with the integration. Okay, so as we go on, we have here, what we can see here, we have here ab over hy minus AB h square y minus b square over 2hy, okay, plus b square over 2h squared y squared, y squared, okay. Sorry, AB, I think I forgot to do something. AB minus h y squared. Yeah, I forgot the y squared. Be careful about that. Okay, and then negative b squared over 2hy. Okay, and let's see, b negative b plus b squared 2h squared y squared. Okay, so far it's all right. B squared minus b squared over h y, okay, with respect to dy. Okay, and we have just this simple integral here, so b will be over h y with respect to dy. Okay, so let's see which are some common terms that we can get rid of. Actually, let's just double check first before we got everything correct. A times negative b h squared y squared negative b squared over 2hy plus b squared 2h squared y squared plus b squared. Okay, all right, so I think so far it's okay. So far we shouldn't be having any issues, I think. Okay, so we can proceed with the integration. Now the limits, the question is about the limits. So since we're integrating with respect to y, we're integrating with respect to the horizontal elements, we're like sort of chopping it off. So our limit is from 0 to h. It's much simpler, right? 0 to h only. So in this case, we can apply the limits and start with the integration. So we're going to put the limits right here also. H and 0. And then we have here a over b hy minus a b h square y squared minus b squared 2hy plus b squared over 2h squared y squared plus b squared minus b squared over hy, okay, respect to dy. And then, okay, integral h0 b minus b over h y respect to dy. Okay, so we proceed to the next page. Rotate it. Okay, cool. So as we try to solve this problem, for 0, if you were to integrate it, you'll always be 0, so it shouldn't be an issue, right? So you only have to just plug in h anyway. So ab over h times y squared over 2 minus ab over h squared y cubed over 3 minus b squared over 2h y squared over 2, okay, plus b squared over 2h squared y cubed over 3 plus b squared y plus minus b squared over h times y squared over 2. Your limits are from h and 0, but just when you plug in h, okay, and then you have here by minus b over h dot y squared over 2. Again, h and 0. Just remember to only plug in h. So as we plug in h, what we can see we get here is ab over h times h squared over 2 minus ab over h squared dot h cubed over 3 minus b squared over 2h dot h squared over 2 plus b squared over 2h squared times h cubed over 3 plus b squared h minus b squared over h dot h squared over 2, and then it's going to be bh minus b over h dot h squared over 2. Okay. So now we come to the fun part, which is just trying to simplify or cut down any common factors, right? And then hopefully we'll get the right answer, inshallah. So we start here, we get h, uh, h, h, and h. Okay, so we get here what? I get here ABH over 2 minus ABH over 3 minus B square H over 4 plus B square H over 6 plus B square H minus B square H over 2. Okay. Alright, let's cut this one as well. Alright, so we'll have here BH minus BH over 2. Okay. So I think we can see some interesting patterns right here. Now let's try to simplify this stuff, yeah? So this is half minus 1/3. So you can say this is just 3ABH over 6 minus 2ABH over 6. Okay. And this is b squared h over 4 and 6. I think the common term would be 12. We can do 12 here. So 3b squared h plus 2, not 2, sorry. 2b squared h over 12 plus 12b squared h over 12 minus 6b squared h over 12. And this would be, the bottom part would be BH minus BH over 2 is clearly just BH over 2. Right, I know it's a bit small, but hopefully you guys can bear with me for this one. Clockwise 90. Alright, let's go. So 3 minus 2 is clearly just ABH over 6. ABH over 6, negative 3 plus 2. So negative 3 plus 2 plus 12 minus 6 would give us 5. Wow, 5. Okay. Plus 5 BH squared. Okay. If I do take out the BH, what am I left with? I'm left with A over 6 plus 5B over 12, right? And I'm left with BH over half. Right, so you can factor out BH. We're left with A over 6 plus 5B over 12. And we times it with 2. I should get 2A over 6 plus 10B over 12. It's supposed to get me 1 over 3A plus 10 over 12 is how much? 5 over 6. 5 over 6B. Let me just double check if I've made any mistakes here before I can be sure this is the correct answer that we've done. H over 3. Double check from the beginning, yeah? So AH times B, ABH minus AB, okay? H squared, Y squared, okay? then negative b times b become negative b square over 2hy plus b square 2h times h becomes 2h squared, and then y squared plus b squared minus b squared over hy. Okay, and this is just as it is. So we put the integrals. Okay, we integrated it. Supposedly we get ab over h y squared over 2 minus ab over h squared y cubed over 3. Okay, minus b squared over 2h y squared over 2. Okay, plus b squared over 2h squared y cubed over 3 plus b squared y minus bh y squared over 2. Yeah, okay. And then we have here just by minus b over h y squared over 2. Okay, so we substituted h inside. We got h cubed over 3, h cubed over 2. So we cut out. Becomes h, h, okay. So 2 times 3 becomes 6 actually, okay. And then this is b squared plus h, and this is just h. That's what we end up getting actually, right? 4. Okay, let me just double check first, yeah. Okay. Okay. Let me just double check if I missimplified the expressions wrongly or not, yeah? Just to double check. Okay, let's start from here. So x2 a minus bh y over yb. Okay, let me just check. Yeah, a minus bh x y. Okay, b, yes. Okay, plus b minus a over hy. Okay, so a over hy minus b over hy plus b minus a over hy. So the difference should be just negative b over hy plus b, supposedly, because it will cancel out. And then when we added these two together, a minus bh y plus b plus a plus h. So a over hy plus a over hy becomes 2 over hy, and then minus b over hy plus b. Okay, over 2. And divide this by 2, so times it halves becomes a over hy minus b over 2a. So you see there's a mistake I made here. So it becomes supposedly b over 2. I forgot this one, right? So then when we multiply it, that's where the mistake actually happened. It becomes b over 2. Okay. So our multiplication for this part's okay. For this part should be okay, but for the last part becomes wrong. So b over 2 supposed to be, b square over 2. Okay, and this one becomes negative b square 2hy. Okay, so 2hy negative, right, becomes negative as well. So let me just correct it right here. B square over 2 and b square over 2hy. Okay, then supposed to be b square, supposed to be plus b square over 2y, right? Plus b square over 2y. Okay, b square over 2y minus b square over 2h, yeah, times y times 2. And we have here, and we also have b square over 2h. Okay, so then we have here, right, and we also have here this part as well. Okay, so with that being said, this one will become negative 3 becomes 2, this one becomes 6 over 12, right, and this one becomes 3 as well. So eventually what would happen is Negative 3 plus 2 plus 6 minus 3. It will cancel out actually. Supposedly it should cancel out, I guess. Should get... Not cancel out, sorry. You'll get this instead. Okay. Right. And then you get here 2b over 12. And then, whoops. 2b over 12. Then you get here 4b over 12. And then when you get 4 over 12, supposedly you get 1 over... Sorry. You get here 1 over 3b. And then your final answer for x bar should be 1 over 3 a plus b, right? And if I'm not mistaken, that is the correct answer for x bar actually. Okay, so that is the correct answer how to get for x bar. So always remember to check for your mistakes actually, like to check if there is any mistakes you have done when solving the problem, because this small mistakes it can happen and you can end up getting the incorrect answer. All right, now let's try to find for y bar. Okay, so to find for y bar, okay, we know that to find for y bar is just simply the integral of y tilde dA with respect to the integral of dA. Okay, let me try to make sure that we got space here right away. We'll try to give a nice line here. Okay, and there. Okay, cool. So y bar would be equivalent to the integral. So y tilde is very simple. Y tilde is just y. So it's just y times our dA. Our dA, as we find it earlier, was... Where is it? B minus b over hy dy. B minus b over hy dy. And the integral of b minus b over hy dy. Again, don't forget to simplify before you integrate. So you get here by minus b over hy squared respect to dy. And you get here integral of b minus b over hy respect to dy. So if we were to integrate within the limits, remember the limits are in this case from 0 to h. So, right, we go to h, we go to 0, we go to h, we go to 0, okay? And then we can start integrating it. So we get here by squared over 2 minus b over h y cubed over 3, h and 0. And this one is by minus b over h y squared over 2 with respect to h and 0. Proceeding on to the next page. Rotate page 90. Okay. So we would have here b h squared over 2. Let me just double check, yeah. All right. Minus b over h cubed over 3 over bh minus b over h dot h squared over 2. Okay, and if you substitute 0, of course you'll get 0, so there's no need to worry about that. So as we proceed, let's simplify this, make this h squared h. So you end up with bh squared over 2 minus bh squared over 3 with respect to bh minus bh over 2. So you'll get here 3bh squared minus 2bh squared over 6. And this one is just simply bh over 2. So you'll get here bh squared over 6 divided by bh over 2. So you get here bh squared over 6 times 2 over BH. Okay, so 1, 3, 1, H, right? So you end up getting 1 over 3H. So your Y bar is 1 over 3H. Okay, and this is also the correct answer as well. So yeah, this is how we solve for this problem. So the Y bar is actually pretty straightforward, because Y bar, the calculation is very easy, since your Y tilde is just Y, you just plug into the equation and then it becomes a very straightforward integration. But your X bar is where the things can get a little bit tricky. I won't say complicated, but can get a little bit tricky if we are not paying careful attention to the terms here, right? Especially with the A, B, we can end up getting mixed up, right? There's so many letters. But just a simple tip to remember is what we're integrating against. We're integrating against dy, right? We're not integrating against a or h or b. So you can always treat those letters as if there were some constants, right? And that will make your life much easier. And when you integrate respect to y and try to apply the limits. All right, in this case we applied h in 0 because we treat h as if it was just some sort of a number. We treat it as if it was a number, okay, rather than a constant, because we treat, I mean, rather than the letter that you're integrating against, right? Otherwise you'll make things a lot more complicated actually. So yeah, this is how we attempt to solve this problem. So first thing to always do is to always choose the right limit, right? Not limit, right? What you call it, the right rectangular element. Because if you choose the rectangular element that is not the correct one, the one that makes your life much harder, then you won't be able to solve this problem within the given time limit for the final exam. So yeah, that's it for chapter 9, finding centroid by integration. I hope this tutorial is helpful for everyone involved. I'll be sending the answer sheet as well, so that you guys can actually sort of follow through the steps and see how I managed to solve it. And yeah, that's it. Take care.